Okay, so our next speaker is Alex Hubner. He's in the Native Plant Program horticulturist and garden steward at the UC Santa Cruz Arboretum and Botanic Garden. His work in recent years has focused on vegetation sampling and seed collection for long-term storage through the California Plant Rescue Project. The title of his talk is A Few Observations of Herbaceous Plant Communities from the fascinating San Joaquin Desert region of the central interior Coast Ranges. Welcome, Alex.
It's a little scarier up here. Everyone's looking at me. There's buttons. All right. So, yeah, as you can see, my title, I don't really like it. I think it's a little wordy, but it's too late to change it now. So, anyway, yeah, so I'm Alex. I'm from the UCSC Arboretum, and I just wanted to share with you a few things that we've been doing in the world of veg mapping. Let's see. So, it worked. So here's our regions that we've been contracted to map over the next 3 years. We haven't gotten to all of them yet. In particular, the Northern California Interior Coast Range there in yellow. If anybody out there knows anybody who has land on that land, please let me know, because it's like 99% private, and we're having trouble getting to it. But I'm not talking about that area today. I wanted to talk about a different area. But briefly, here's most of our team. They're all here today. So team, everyone team. Nice to meet you. Especially my wife, Lucy, right there. I wouldn't be anywhere near here without her. And of course, Brett Hall, the man with the plan. I also would not be here without him. So thanks a million. Anyway, let's hit the road. That's our botany canine unit, Margaret, and she goes everywhere. But yeah, let's hit the road to the area in question. I want to talk about a certain part of our southern interior coast range that we've been contracted to sample, and it's called the San Joaquin Desert. And I've roughly circled the area that we've been in there in yellow. And I think it's one of the most underappreciated parts of the state, really. It's, most people drive by it on the Highway 5 and look out the window and they see these low, kind of uninviting hills and they think, when's the next In-N-Out burger? But I think there's a lot more to it, and especially because rain makes all the difference. Here's photos I've taken of that area in March of 22 and 23. And it makes a difference, It's pretty barren without water. And we got really lucky being contracted to start in 23 like we did, as you can tell. There's a lot more to look at. So yeah, about these herbaceous wonders that we were sampling. The current edition of the Manual of California Vegetation doesn't have a ton to say about these. There's kind of a lot of blank space. I know that there's a lot of work being done on that. But at the time, we didn't have a ton to go off of. But we were lucky to have our friend here, Ryan Odell, who's the natural resource specialist for the Central Coast field office, the BLM, and he's brought us to every little interesting nook and cranny of this region. Nobody knows more about it than he does, and he also made his own kind of local vegetation classification system that we got to rely on very heavily to tell us what's a thing and what isn't. So here's a quick slide. I don't expect you to get much out of this by looking at it right now, but as you can see, it's organized by alliance and association, but then also primarily up here at the top, going back, by soil types. And in this region, it makes a ton of sense to do that, to account for what you're going to find and where by the soil type, and then also things like aspect and disturbance. So, as you can see, there's the sand, and then I keep pressing that wrong button. So there's sand, and then there's active sands, which are wind-blown sand dune type stuff, and then there's inactive sands, which is like sandstone, and so on and so forth. Here's the other side for clay. There's light clay. There's heavy clay, as he calls it. And we'll get more into that as we move along. Let's take a look. So the first spot we went to is the Kettleman Hills, and these are the low, uninviting hills I was talking about that you pass by on Highway 5, kind of nearby Coalinga. And they're real beautiful when it rains. Even if they're kind of a little spooky, there's like oil derricks and pump jacks and rusty pipes sticking out of these big beds of Phacelia tennessetifolia and other things. But I had fun. I like it there. And let's see. Okay, so the next spot we visited was Martin Ranch, which is maybe 30, 40 miles north of there. And it's a gigantic private ranch. It's super rugged and very beautiful. And it's kind of it's like a living textbook or something for the differences between vegetation and soil and aspect and disturbance and all these other things. A lot of these plants people might be familiar with if they've been to the Carrizo Plains, but there's also more interesting, more rare stuff that occurs basically only in these areas. And hopefully I'll be able to get into that. Let's see, where am I? Here's more Martin Ranch. That's kind of up in there, like over that hill is like Clear Creek Management Area, if anybody knows where that is. So yeah, here's a good example of like soil type and vegetation type. And there's like, so up top here is like a sandstone formation, and then right below it, you can see that line, and below that is an acidic marine shale. And so you can see how like this one slope could keep you pretty busy by, like hiking all the way up there and then trying to hike back down without having to sample every little nook and cranny. Here's a good example of like aspect, so, yeah, what did I call that? So yeah, there's Monolopia major on this side, where it's shielded from the sun, and then over here, getting full UV treatment is Eriogonum nudum indictum. So anyway, moving along. Here's Eriogonum ordii, this kind of pink cloud-looking thing that occurs only on like the steepest slopes of clay soil where it's been like actively sliding when it gets wet. So yeah, back in the Kettleman Hills, here's our active sands. This is like a big sand dune that happens to live in the Kettleman Hills. And you can see that like it's very active indeed. This is what occurs down in kind of the lower slopes up against that big sand dune. But up here, the sand blows like too violently and sandblasts everything out of existence. So all the good stuff occurs down where it's a little bit more sheltered. And so what we have here is like what Ryan O'Dell classified as an alliance of Oenothera deltoides and Abronia pogonantha. And then there's Calanthus inflatus, which was like over 6 feet high here. And it's pretty cool, I think. We spent a bunch of time just kind of hanging out there and taking pictures. There's another picture. And so Ryan O'Dell, he has the Calanthus inflatus as an associate of underneath the Abronia pogonantha alliance. And he has it as an alliance of Abronia and Calanthus because, and we like our surveys seem to make sense of this because like as the Oenothera cover tends to go down, it tends to be replaced by Calanthus density on the ground, and it seems to have something to do with relative disturbance of the sand. Like the Calanthus doesn't seem to like super active sands, maybe because it tips over or something. But anyway, that's just a conjecture. That's out of my pay grade. I'm talking, conjecturally here. But yeah, you can see here at Martin Ranch, there's very little, Oenothera, one or two here and there, but the Abronia seems to stay static and be replaced by Galanthus cover. Anyway, it was a bumper crop year for these sphinx moth caterpillars, particularly on this site. And we came back later in the season, it had been completely defoliated, and you could hear them crunching everything. They seem to have an affinity for I'm pulling a blank. Anyway, that, yeah, like the Oenograceae stuff. Let's see. Okay, so here in this video, I'm going to show you after they had defoliated the stand, they were trying to make their way across the Sahara Desert and were being turned back. And in this video, it also shows something about the active sands and how violently they do. But I don't know if I can even play this video. Is there a way to do that? You'll have to take my word for it. I'll email it for you if you ask. But imagine little caterpillars crawling up and being blown back down violently. And it's very sad and dramatic. Let's see. Oh, wait. I did it. Poor little fellers. The thing is, there's nothing over on that other side of the hill, which makes it extra sad. Okay, the next type is acidic marine shale, which is another pretty common soil type you find in this area. It occurs on the valley floor here in one type, and it's like, this is back at Martin Ranch, by the way, and it's like the only place you find woody vegetation. There's a big band of it that runs through the center of the valley, miles and miles and miles long, with the hybrid Alvord oak and Juniper californica, and it has pretty low herbaceous cover, and what there is tends to be pretty ephemeral. It comes and goes. Here's another angle on that. But then also on this, well, this is down below still. But then up on the slopes, you get stuff like this. This is also acidic marine shale. And you can start to see some of the interesting differences in soil chemistry, which I have been able to make very little of, except that they like to support different plants. Right here we got, I've completely lost my place in my notes here. Okay, so we have like Eschscholzia hypocoides and an alliance up here or something. And then below it is Canactus. It's a new species, Joaquin. I think Bruce Baldwin is working on having that one published. But here's like panned a few degrees to the south, and you can see that band goes on and on and on. Both marine shale, right next to each other. I don't, maybe one's more acidic than the other. I'm not sure. Another alliance or type that we called an alliance that we surveyed in marine shale is the Malacothrix floxifera, Eschscholzia hypocoides, and Amsynchia furcata. And I thought it was pretty enough to put on the slideshow. Okay, lastly there's verdict clay, and little paw there shown for scale. And verdict means that it expands and contracts violently and dramatically depending on how much moisture is in the soil. So it will make these big fissures or and then expand and turn into this kind of axle grease mess that God help any botanist that tries to drive over it, because it will. I mean, an Abrams tank would get stuck in that stuff. So yeah, and this is the soil where most of the rare stuff occurs in the area, so yeah, there's some kind of interesting clay bubbles. That whole thing's clay. It's like more clay there or something. That's why it's bald. Up close, back in the Kettleman Hills. And here is a nice escarpment of actively moving clay, again with that Eriogonum ordii is that little pink cloud there. It's very hot when you go into these little areas. to survey. It's kind of like a lens for the sun. So yeah, here's some of the rare stuff that occurs in this clay. Navarisha panocensis, Mattia radiata, that one's real pretty. There's also some new ones that are, so Ryan Odell's working on getting this one to be made a real species. I expect someday it will be. And here's another one, Atroplex, Canactus. That one also shows up on marine shale too, but the clay is like a weathered version of the marine shale, so it's not necessarily a surprise to see the same plant occurring on both types. And that's about all I got for you. So. Oh, time for questions. The questions is the scary part. I haven't prepared for your question yet.
You just said it's a good question.
Yeah, I mean, totally. Yeah, I'm sure it will be.
One of the issues with classifying the annual vegetation, annual dominated vegetation, is year-to-year differences in the same place. You could go sampling the vegetation in this past spring and see quite a different assemblage of plants than you would during a different year when the rainfall came in different amounts or in different time frames.
Absolutely, and I would just add to that that even over the course of the same year, you can return to the same spot that you were in spring and come back in late summer, and it's totally different vegetation cover and, you know, equally dense cover and equally interesting, but it doesn't resemble what was there just a few months ago. So, yeah.
In addition to the landscape variables you were noticing, what role did disturbance histories play in what you found in these spooky hills?
Well, the main ones were just like the ones I would talk about were also, it was like whether or not the sands were being actively moving and blowing around, or if they were kind of stratified into a sandstone-like aggregation, or if the clay slope was, you know, solid, or if it had been sliding over the course of years, or also like the clay, the verdict clay tends to like expand and contract, and it'll dry into this kind of grape nut-like consistency and then crumble and then re-harden into like a, you know, a pool again. And that churning effect seems to be very, very rough on plants, and there's like only a few ones that can exist on that churning substrate. There was, you know, animals moving about, but it didn't seem, you know, the animals had, most of what we saw was a few years old and didn't seem to have a tremendous effect. So, sorry.
Okay. So I'm just, one, I really appreciate the association with the soils, and I'm curious, were you guys identifying areas to target based off of web soil survey or geological stuff, or did that kind of come after you found the differences in the community types?
That was all Ryan Odell.
Okay.
I can give you his email if you're curious. He's very, very helpful man.
Cool.
So, yeah. Is that it?
Thank you so much.
Okay. Thanks.
Great talk, beautiful pictures.